Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic organic chemistry and specifically organic chemistry 1. So, today it's just a continuation of what we discussed in the previous lesson, where we were looking at the chemical properties of alkenes. So, we looked at addition reactions and also combustion. So, for the addition reactions, we saw hydrogenation, halogenation, and hydrohalogenation. So, for today, we are going to look at polymerization and reaction with oxidizing agents, and then we are going to look at some few uses and do some questions. So first of all, self-addition or addition polymerization is a process where small unsaturated monomers, so you note the word monomer because you're going to be using in this process, from alkene molecule join together to form large saturated molecule. So we have monomers. Monomers are actually the alkenes we are combining, and then we form large molecules we call polymer. So you can see from the word monomer, we just add a poly to show many. So it's many alkenes that have been put together. So only alkenes undergo addition polymerization, as we are going to repeat later on. So addition polymers are named from the alkene or monomer making the polymer and adding a prefix poly before the name of the monomer. So if you have an ethene, it's polyethene. If it's butene, it's polybutene. If it's propene, polypropene. You just add a poly before the alkene name to form the polymer. So for example, you can see from the ethene, as you can see, and you can see in this case, if we use n number of monomers or n number of ethene, it's going to form a very large unit, and we can close it down and say they are n because it's continuous. So if you pick a small unit that is repeating itself, we call it a repeating unit, and you can see we only pick a monomer, a structure of like a monomer that is repeating itself. So let's see how polymers form in other alkenes. It is important to see this part because you're able to distinguish them very easily. So we'll start with ethene. I need to go back to showing you ethene because I want you to compare with propene and butene. So for ethene, this is how ethene looks like. So this is the monomer. If I add another ethene, I'm going to form a compound with 4 carbons, and we remove the double bond. So I put the hydrogens as they were, but it doesn't have the double bonds. And in this case, I'm going to enclose with a bracket to show they are exact. You can see there are just 2 of them. But if it was to add uncountable words or n, I would add an n here. But because they are specific, that's the reason why I'm not adding an n. If you were to pick a repeating unit, we'll just come here and see how it's repeating itself. You can see it's these 2 and these 2. So a repeating unit is just you pick one part of the polymer as it is without double bonds. And remember to put the bracket, and remember it's repeating itself how many times? 2 times, because you can see the repetition is 2 times. So in the cases where we have the repeating units going on and on and on, we usually put n. So remember, this is monomer, this is another monomer, this which is as formed is called polymer. And this case the monomer is ethene, the polymer is polyethene. So let's see the difference between this and propene. So when we write propene, we don't put it like this. Because if you put it like this, you notice when you are opening or removing the double bond, it's going to look similar like this one. So we usually differentiate it by changing the structure of propene. So this is how it's going to look like. So we write 2 carbons with a double bond. And then the third, we are just going to press it. It looks like a branch, but if you look at the longest chain, it is accurate. It's just a propene, as you can see, but the only difference is that we have changed the direction of the longest chain. So if we add this with another propane, another monomer of propane, remember it's just propane, it's just the direction that we have changed. So our polymer will look like this. So you put the carbons without the double bond, and there are four of them, here with a CH3 and also here with a CH3, and the hydrogens and hydrogens, 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 hydrogen, hydrogen, and then we enclose it with a bracket. And since there are two, we do not have to put a specific number outside. So we can pick a repeating unit, and this is the unit that is repeating itself. So the repeating unit is going to be two carbons with a hydrogen and hydrogen and a CH3 here, and a CH, no, there's no CH hydrogen, and then enclosed, and they are repeated twice. So for butene, you repeat the same thing, just changing the direction of the longest chain. So double bond. So you put a CH3 here and a CH3 here. So it's just butene, but the direction is a bit different from ethene. So we add another one. So if we add these two together, we are going to form two carbons, CH3, CH3, or you can even put it the other way around, it's still okay. You can put the CH3 at the top if it's going to help you to remember. So that's how it looks like. If you were to repeat a repeating unit, it would be C, H, H, and then CH3 and CH3. So I was saying you can still put it, the monomer, you can put it like this, CH3 and another CH3 here. It still works. It's just the direction of the longest chain you have just changed. So those are how we form polymers from alkenes. So this will be polypropene. This is going to be polybutene. So the next addition reaction is with oxidizing agents. So alkenes usually are oxidized to alkanos with the reaction of oxidizing agent. For example, some examples of oxidizing agents are potassium dichromate 6 and also potassium permanganate 7. Remember, these oxidizing agents needs to be acidified. So for example, when alkenes are bubbled into orange, note the color is important. Acidified potassium dichromate 6, the color of the oxidizing agent changes to green. So it changes from orange to green. And then when it's bubbled in purple, note the color as well. Acidified potassium permanganate 7 solution, it is decolorized. Basically, it's changing from purple to a colorless solution. So for example, if you react ethene with an oxidizing agent, as you can see, so remember the reaction occurs along the double bond. So this is where we are adding the OH. And remember the acid produces the hydrogen ions and the oxidizing agent gives the oxide ions. That's why we are adding OH across the double bond. But you can see it's forming an alcohol but is having two OH. So that's why we call it diol. We are going to look later on at organic 2 and see how the alcohols are usually named. Another addition reaction is hydrolysis. So hydrolysis is the reaction of alkenes with water or the addition of water into the compound. So it usually undergoes with a few steps. So the first step is the reaction of the alkenes with sulfuric acid. When they react with sulfuric acid, they form alkyl hydrogen sulfate. So for example, if you look at this ethene here, we are reacting it with sulfuric acid. This is how the structure of sulfuric acid looks like. So basically, we are going to add this part without the hydrogen. We are adding the whole of this part into where we are removing the double bond and introducing, and you can see the hydrogen attaches itself here. So if we were to draw, let me just show you that. So one of the hydrogen will attach itself in this carbon, and then the rest of the sulfate will attach itself in this carbon. So we end up having an hydrogen from the acid. So this is the hydrogen from the acid, and then we have the sulfate, this one, which comes from the sulfuric acid. So we end up forming alkyl. So alkyl is this part with two carbons. So for example, it will be ethyl because of two carbons. So ethyl and then hydrogen sulfate. And then this ethyl hydrogen sulfate is going to react with water. When it reacts with water now, these sulfate ions are interchanged with hydrogen ions, and then these sulfate ions are replaced with hydrogen ions to form now ethanol, and then sulfuric acid reacts with the rest to form the hydrogen sulfate reacts with the rest of the OH ions to form sulfuric acid. So that's how hydrolysis occurs. And remember, this happens in presence of the acid and water, and it needs to be warmed. So let's look at a test for alkenes. Initially decolorized bromine water and also acidified potassium permanganate 7. And then also this tells us that the reactions have, or the reactants, which is the alkene, has a double bond. And some of the uses of alkenes are used to form plastics through polymerization. As you saw earlier on, they could undergo polymerization. There's also manufacture of ethanol through hydrolysis reaction, as you saw with the reaction of ethene with water and sulfuric acid. It is also used in ripening of fruits, and then it also ethene is used in the manufacture of ethane 1,2-diol, which is used as a coolant. So you do that this one question to help us to understand how polymerization occurs. So the following structure represents a part of a polymer, given that the molecular mass of the monomer is 76.5. Answer the questions that follow. Identify and draw the structure of the repeat unit. So we are going to identify the repeat unit. So you can see CH3 is repeating itself after every one carbon. So this tells us this is the repeating unit. So we are going to just draw that one more time. So we have a CH3 here and hydrogen, chlorine, hydrogen, and then we are just going to put N because it's being repeated N times. The name of the monomer. So the monomer is having a double bond. So we introduced the double bond as it was before. Be very careful. So you notice this, the longest chain has 3 carbons. So this is chloropropene. Remember, it comes from the alkene, that is the monomer. And then what is the molecular formula? I've already drawn the molecular formula. So there's a common question for you to look for the value of N. If you were to look for the value of the number of the monomers that were used to form the polymer, let's look at such a question so that I can be able to answer that question for you. So below is a section of a certain polymer. Study it and answer the questions that follow. Identify the polymer. So this is going to be 2, 2. This tells me we have 2 carbons in the monomer. So this is a polyethene. If you were to draw the monomer, you just draw the ethene. So 2 carbons to introduce the double bond, hydrogen, 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 hydrogen. And then name the type of reaction which forms the above polymer. We called it polymerization. So a section of this polymer was found to have molar mass. So the molar mass of the polymer is equals to 1875. So for us to determine how many monomers made up this polymer, it means the polymer is equals to monomer plus monomer plus monomer, like that, like that. depending on the number of times, which we'll call n. So if you take the molecular mass of the polymer, it's the same as if you take the total molecular mass of monomers, making multiplied by n or a specific number, you get this mass. So in this case, this means if you take 1875 is equals to the monomer, the molar mass of the monomer is ethene, it has 2 carbons, that is 12 times 2 plus 1 times 4. If you multiply it n times, you're going to get 1875. So 1875 is equals, this is 24 plus 4, which is 28n. So if you divide by 28, it tells you how many monomers were used. So note it's 1876. Let's not make that error. So the value of n is 67. So it tells you 67 monomers were combined to form the polymer that had a molecular mass of 1876. So that brings us to the end. So we are finished up with alkenes. For the next lesson, we are going to be looking at alkynes. So see you in the next lesson.